alternating current. So in 10th standard students, we have seen that when a coil, okay, suppose I have one coil like this, and when it is, suppose it has n number of turns, and when it is kept between two horseshoe base magnet, this is suppose north pole and this is suppose south pole, when this will kept in the two poles, in between two poles of magnet, so and when it is rotated around its axis, okay, so EMF is induced, or you can say current produced, and this current we call as alternating current. But when we came in 12th standard and learned chapter electromagnetic induction according to Faraday's law of electromagnetic induction, so we've seen that EMF is induced, okay, and basically there is a most important term is what, flux, okay. So lines of force emerges from north pole to south pole like this. This is the direction of lines of force. So when these lines of force were cut by these this coil, so current is flowing or EMF is induced, okay. And when we'll do derivation, so suppose n is the number of turns in the coil, and A is the area of this coil area, and B is the magnetic field produced by this horseshoe base magnet, and suppose theta is the angle, between magnetic field and area, okay. So at an instant, so when we find out flux, so flux is given by BA cos theta. Since this coil is rotating in circle, so this theta is the angle, so we can write it as BA cos omega t. This is what flux, okay, because suppose any particle is rotating in angle, so this is what angular displacement theta, okay, and angular velocity is omega and t is the time, so angular displacement nothing but angular velocity upon time, so therefore you can write angular velocity is not angular velocity, omega is equal to angular displacement upon time, so you can write theta is equal to omega t. This is what we have used here, omega t, okay. Now this is what flux, and according to Faraday's law of electromagnetic induction, flux rule, we want to know that how much EMF is induced in this coil. So that can be found out by differentiating flux with d phi by dt, and this flux you can calculate now. So minus d by dt of, and suppose here is the n number of turns in the coil, so this become n AB cos omega t. So n B A cos omega t, this is what you have to differentiate. When you will differentiate it, you will get EMF induced. So E is equal to minus, now this n is number of turns, it will come out because it is a fixed number of turns. B is the magnetic field, it is also fixed, this magnet will not change its magnetic field, and A is the area of coil will also not change if it will rotate and current will flow. So means you have to differentiate d by dt of cos omega t. Now this we are differentiating with respect to time, so according to rule of differentiation, this omega will come out, so what you will get, minus n b a omega, and this will come out, and differentiation of cos is nothing but minus sign, so one minus is here and minus sign, this become plus, and this is sine omega t. This is what your EMF, this much EMF is induced in the coil, okay, that is nba omega sine omega t. Now students, see, this is sinusoidal function, and if I will plot the graph of sinusoidal function with respect to time, so what I'll get some graph like this. Okay, it means sometime it will increase, then become 0, then again it will decrease in negative y direction. Okay, so I want to know that when this EMF will be maximum, so it means when sine omega t will be maximum, when sine theta will be maximum, that time this EMF will be maximum. And when it will be minimum, so when sine theta will be minimum. So when sine theta is maximum, so basically when theta is equal to 90 degree, sine theta become +1, and when theta is equal to 0 degree, so sine 0, basically here it will be 90, sine 90, sine 0 is equal to 0. Okay, it means I can write in case of this first term, okay, when it will be maximum when sine theta is equal to 90 degrees. So you will get maximum EMF is equal to NPA omega. Now this is what maximum value, and this we will represent E naught. Okay, this maximum value E naught is equal to NBA omega. It means what? EMF induced in the coil, in this coil, you can see this in this coil is depend on what? It depends on number of turns. If you will increase number of turns, then EMF will also increase. That is second term is magnetic field, number 3 is area, and number 4 is omega. Okay, so these are the term, and this will give you maximum when sine theta will become 90 degree. Sorry, yes, 90 degree. Okay, so we will call it as peak value of EMF. Peak value of EMF. See, this is the peak value here. It will be reverse, but it will be maximum in reverse direction, and this is what peak value here. Okay, because it is at peak, so here you will get maximum value. So therefore now our EMF become E is equal to E0 sine omega t. This is what EMF induced. Okay, and therefore it is continuously changing its direction, you can see in the graph. Okay, so because of this continuous change in direction, we call it as alternating EMF. Okay, now this is alternating EMF. Now what is the current? How much current is produced? Obviously in this coil, suppose EMF is induced, this much EMF is induced, E is equal to E0 sine omega t. So how much is the current? So we know that I is equal to E by R. So when I will write, that is, see, now here we are dealing with AC current, so instead of V, which we are using in DC, okay, we will write here E, that is EMF, electromotive force. So this is, suppose capital R is the resistance, so what I can write here, E0 sine omega t divided by R. Now for given combination, number of turns and magnetic field, area, theta, okay, this peak value is fixed here. This peak value is fixed here. So this is a fixed quantity. R is the, suppose, the resistance you have connected, or resistance offered, okay, by the coil. So you will get here one more quantity, and it will give you maximum value. Suppose for an example, suppose when here, even in case of this, so sine theta will be maximum when theta become 90 degree. Okay, so in that case we will get peak current I0 is equal to E0 by R. When we will get this, when sine theta omega t become sine angular, you can say theta is 90 degree. Okay, so here, so I can write here I, therefore I is equal to I naught, sorry, sine omega t. This is what? Current. Okay, and this I naught is called peak value of current. Now look at this equation, E naught and E naught by R, this quantity. So basically E naught is basically EMF, okay, peak value of EMF, and you are dividing something R. Okay, so you will get less peak value of current compared to EMF. So from this equation you can see here E equal to E0 sin omega t, and here I equal to I0 sin omega t. Okay, so it means you will get less current in this case compared to EMF if you'll plot the graph. Okay, let me show you how you can plot the graph. Now suppose I will take this is one axis and this is time axis. Okay, so this is, suppose I am plotting for EMF for one complete cycle. Okay, this is plus E naught and this is minus E naught, this is 0. Here you can write T or omega t. It is very important to write here E or T or omega t. And current, in this case we are getting E naught, this is E naught divided by R. It means your current value in the graph will be less. So you can plot like this, but both are sinusoidal function. You can see here we are getting sin omega t, and even this case of EMF, this we are getting sin omega t. So both are the same waveform. Okay, but current is less compared to EMF, so you have to draw like this dotted line. Like this. So this will be your plus I naught and this will be your minus I naught, peak value of current. So this is the origin of AC generator or AC current, that is alternating current. This is what origin, basically how we started. Okay, now this AC current in case of DC, let me go to the next page. In case of DC students, so if I'll plot in one graph AC and DC both. Okay, so AC is like this. This is T here and this is what DC, straight line. This is DC and this is what AC. Okay, this is for complete cycle. Here it will be capital T. So we know that what is peak value I naught, peak value of current I naught, peak value of EMF, that is E naught. Okay, now some terms are related like amplitude, frequency, as we already defined. And if you look at this graph, so average value of AC is 0 for one complete cycle. AC average value of AC is 0. Okay, and then but in case of DC average value is not 0. Okay, so this is what, so beginning of alternating current. And next part is, which is very important, that is what Phasor diagram. Okay, so we know that when we connect different electrical component like resistor, capacitor or inductor, so AC and AC EMF and AC current are not flowing in the same phase. Okay, so therefore we need a diagram which can represent AC and AC current and AC voltage, okay, in one single diagram. Okay, so what we can see here, but before going to the Phasor diagram, first let's discuss what are the advantages of AC and what are the disadvantages of AC. Okay, so there are many advantages, okay, and some disadvantages also. So basically a advantage of AC is basically generation of AC is more economical than DC. Okay, it is easy to produce alternate current compared to direct current. And the second advantage is like alternate voltage can be easily step up or step down. Okay, you can increase or decrease the voltage by using simple transformer. And next advantage is alternating current can be reduced by using a choke coil without any significant wastage of energy. Okay, like you can control the alternating current by connecting resistor also, but in resistor you will get lot of amount of heat it will produce when you will connect AC to a resistor. Okay, but in choke coil is a special purpose device which is used to control the alternating current, and there is no wastage, very less wastage of heat energy. Alternating current can be transmitted to very distant places, okay, without any significant line loss. Line loss means basically if you transfer the DC over long distance, but so there is a loss of energy, but in case of alternating current it is very less. Also AC can be easily converted into DC by using rectifier. In semiconductor, we have seen that AC can be converted into DC by using rectifier and some capacitor. Okay, so and AC in case of industrial application also, AC machines are very simple. Okay, and do not require much attention during their use. Okay, so this is the advantage of DC, but there are some disadvantages also. What is disadvantage? Like peak value of AC is high, like it is dangerous to work with AC. Okay, because its peak value fluctuate very much. In phenomena like electroplating, electro-refining, electrotyping, etc., AC cannot be. You know that AC is continuously changing its direction. Okay, its direction reverse in every half cycle. Okay, so electroplating, like we do electroplating to basically when we put a layer of metal on any other substance. So we use electroplating in industry. Okay, so that cannot be used because of change in direction. AC is transmitted more from the surface of conductor than from inside. Basically, there is a skin loss. It is called skin effect. Okay, but this is not in the case of DC. So some disadvantage, but many type of advantages are there in case of AC. Now to represent in phasor diagram. So basically, what is phasor diagram? Name itself suggests phasor, means phase. So what is basically phasor? So it is basically a diagram that represents alternating current and voltage of the same frequency as a rotating vector. Students, we know that this AC is generated because of rotation of coil. Okay, so when coil rotate, so it's because of its angular velocity, its EMF and current also changes in angle. Okay, so this is what basically rotating vector, along with, if we'll take proper phase angle between them, it's called phasor diagram. Sometimes it's called Argand diagram. Okay, it's called Argand diagram. So in exam, if it has represent Argand diagram, so don't get confused. It is what basically same phasor diagram. Now suppose omega is the angular velocity. Okay, so let's draw a phasor diagram. Let's take some cases. Suppose this is a xy coordinate. Okay, and so suppose alternating EMF and current in a circuit are given by this equation. A is equal to, here I am writing, A is equal to A0 sin omega t, and I is equal to I0 sin omega t. Suppose there is phase angle, phase difference, so you can write some phi. So phi is the phase difference. So sin omega t plus phi, it means what? Current is leading EMF by phase difference phi. Okay, so now let's draw it. So basically we draw a circle. Okay, so this is suppose circle. We have to draw two circles, one for EMF and one for current. Okay, so suppose EMF is at angle omega t, and current is at angle, suppose this is current, it is angle phi, that is phase angle between current and EMF. So this is, here you will get peak value, maximum value of EMF, and here you will get maximum value of current I naught here. Okay, and so when we will do projection, so if you will do projection like this, so here we will get this projection as EMF here till here on y-axis, this is EMF, and if you will do projection here, so this is what basically your current. Now this line, suppose this is O, this is A, this is B here. Okay, so OA represents maximum value, that is magnitude of EMF, and OB represents magnitude of current. Okay, and this is what phasor diagram how we represent it, and this angle is called phase angle between current and voltage. Now by looking, see, we have drawn this diagram by considering this equation. Actually this phase diagram is decided by these equations. Okay, in case of capacitor we will get different equation, in case of inductor we will get different equations. So accordingly we will draw. So what is technical point here? You can see here I0 is equal to sine omega t plus phi here, and here it is E0 sine omega t only. Okay, so this is what basically E is equal to sine omega t, and if we'll do plus phi, so you will get this current value here. Okay, so means there is phase difference of phi between current and voltage or EMF, you can say. Now if suppose in this case we can say that current is leading, देखो current यहाँ पर आगे है. Okay, so current is leading EMF by phase phi. Okay, if I will do, if current, suppose if current lags behind the, अगर current पीछे है EMF से, so this by phase difference, so this currents become, this equation become I0 sine omega t minus phi. Okay, so you have to draw another phasor diagram. Okay, so here it will be EMF and here it will be current. So this line will be current and this line will be EMF. Okay, so this equation depends on, this diagram depends on the equation, basically relation that we will find out with the help of derivation. So this is what basically phasor diagram. So how you can define phasor diagram? So basically it is a diagram that represents alternating current and voltage of the same frequency as rotating vector along with proper phase angle between them. Okay, and it is sometimes also called argand diagram. Okay, so same frequency means what? So we know that how AC is generated when we rotate a coil. Okay, you can see this diagram, when this coil will rotate. So when this coil will rotate, so current and voltage both will change. Okay, so but they will related to same frequency. Okay, at same frequency current and voltage are changing, so therefore same frequency is important word. So let me write the definition what is phasor diagram. So a diagram, you can define it like this: a diagram that represents alternating current and voltage, alternating current and voltage of same frequency. Same frequency is very important word. Same frequency as rotating vector, as rotating vector along with proper phase angle, along with proper phase angle between them is called phasor or argand diagram. So this is what phasor diagram. So why this is important? Because next in next topic, like now we have, earlier people use DC current. Okay, but after the discovery of AC current, so researcher or scientists connected this AC current to resistor, then they connected to capacitor, then they connected this AC to inductor. Okay, so they found that there is different phase angle, okay, between EMF and current. Okay, so therefore we know how to represent this phasor diagram. So after that our topic will be AC current containing only resistor, then AC current circuit containing only inductor, then capacitor. So in that topic we will see what is phase angle, what is phase diagram, and that is very important for exam point of view because they ask most of the time. So the remaining part we will do in next class. Okay, next video. Thank you so much. Okay, so let's start with AC to resistor. So when we will connect the alternate current to a resistor, so what will happen, what is its waveform, we will see in this derivation. So students, so this is the AC source, symbol of AC source, okay, this symbol AC source, and this is resistor R. So here we are directly we can write EMF is equal to E0 sine omega t, and according to Ohm's law, I is equal to E by R. So what you will get here, so E0 sine omega t by R. So when you will look at this quantity, okay, resistor and EMF, okay, so this is peak value of EMF. So this quantity will be fixed when you will see sine 90 will give 1. So at sine 90, so you will get, this is maximum value. Sine 45, this become 1 by root 2, so you will not get maximum. So when this omega t or theta will be 90, then you will get maximum value of current, and this is, we call it as peak value of current. So I is equal to I0 by I0 sine omega t, where this I0 is equal to E0 by R. So look at the peak value of EMF, this is E0, and peak value of current I0, which is nothing but E0 by R. It means peak value of current is less than peak value of EMF. So while plotting out, we have to look for, we have to take care of this concept. Okay, so now important thing is what? So this is equation of EMF, and this is the equation of current. Both are sinusoidal function, both are sinusoidal in nature. Okay, so when you will plot the graph, okay, so your graph will be like this. This is your y-axis, and here most important part on x-axis, that is omega t or simply t. Okay, and first plot the graph for EMF. So this is graph for EMF. Only one complete cycle is enough, and this is 0. This is the peak value of EMF, that is nothing but E0, and this is peak value of EMF minus E0. Okay, now you know this I0, when you will plot the graph for current on the same axis. So last time while teaching the definition, I told you same frequency. Okay, so both EMF and current are changing, but frequency is same because coil is rotating with the same frequency. Okay, so same axis is there, therefore. So when you will plot the graph for current, so it is always plotted as dotted line, so but it will be less, but both will vary in same manner, like it is also sinusoidal, you can see in the equation. So this is what sinusoidal. Okay, so this is E is equal to E0 E0 sin omega t, and this is I is equal to I0 sin omega t, and this is, you have to draw this line as a minus I0, and this is what, plus I0, this is plus E0. This is what graph of E and I versus omega t. What is this graph is called? Graph of E versus E and I versus time or omega t, you can write here, time or omega t. Now important part is how to draw phasor diagram. Very simple phasor diagram. Okay, so let's draw y-axis and x-axis first. So let me draw it. So suppose this is your y-axis, this is your x-axis, and here write x, this is y. First draw for EMF. Okay, so EMF is greater in magnitude compared to current. So this is your EMF, and this line, this from this tail to this head, is this length is magnitude of EMF. Okay, and you can draw one line. So this will give you E0 sin omega t. Now from the equation you can see this current is less, so anywhere here you have to select one point. Okay, and make an arrow, and this is right I0, that is peak value of current, and draw one line. This is what this is. You can write I0 sin omega t, and this is initial angle omega t. Okay, and since they both are in same phase, you can look at this equation omega t, even here omega t, there is no phase difference in case of resistor. Okay, so it means when you will switch on this circuit, so current and voltage vary in same phase. Okay, so therefore there is no phase difference. So this is your phasor diagram for current and voltage in case of AC current. Okay, so this is how you have to draw. Okay, now similarly we will derive for inductor when we will connect inductor to a AC source. Okay,